In the following problem, we're going to plan the synthesis of propanoic acid. 1, 2, 3. And this is from butane. 1, 2, 3, and 4. So what we see here then is that we have one less carbon. We have 3. So we need to find a way to cut that. But we know that we can do ozonolysis reaction. For example, will give me compounds that have one less carbon. And if you remember, doing ozonolysis of an alkyne, so if you did that, you're gonna form, in the case of a terminal alkyne, you're going to form here a carboxylic acid. Here you will have 2 carbons. So here you will have acetic acid and carbon dioxide. So I know that I can do that. I need to come up with an alkyne that actually needs to have 4 carbons. So when I do the ozonolysis, I lose 1 carbon and I will have my carboxylic acid. So I need a carboxylic acid of 4 carbons. And an alkyne, I'm sorry. I need an alkyne that will have 4 carbons. So I'm going to write it down. 1, 2, 3, and 4. I need that alkyne so that I can have the acid that I want. So now how I make the alkyne from butane. Okay, that's our goal here. So first step, we need to do something that is called functionalize. So add a functional group to an alkane. It doesn't have any. So what we do here typically is a free radical reaction in which we're going to be adding halides to that. So how do we do that? If we do a bromination, for example, light, we're going to do a halide that is interesting for us, a dihalide. So bromination is selected towards, well, more to secondary positions than primary. So that's a product that you will have. And now here, once that I have functionalized the alkane here, I can do an elimination. And here, if I use an excess of sodium amide, let me do that and just try another color. If I have excess of sodium amide, I will do here 2 consecutive ether reactions. Remember that we can make alkynes, we can make them from either geminal, which is this case, from geminal, so having dihalides, or also vicinal. So in this case, I have a geminal. I can do consecutive elimination ether reactions, and that way I will be making the alkyne that I need. So why me? I make that. So the synthesis came out basic. All we need to do is that then do the functionalization. We use bromine. We do the dihalide. This is 2 eliminations. Remember, if you did that in step, let's do the intermediate, but we have an excess. We will have first, you're going to form the alkene, but in the second elimination, again, you're using an excess of sodium amide. You're going to make the alkyne that you need. Last step is then the ozonolysis. So summarizing, to make propanoic acid from butane, what did we do? First step was doing bromination, and then we did a second step, which was treating with an excess of sodium amide. And the third step was, I'm going to write it down here, ozonolysis, okay? So that is, in summary, what we need to be doing to make that acid. But notice, over the strategy, you need to count the carbons. We had 3 here, we have 4 here, meaning that we need to remove 1 carbon. Also notice this is always a good strategy to remove carbons.